Okay, we're ready to begin our tech talk today on improving CAM workflows with NX Toolpath animation. For questions, as you have questions on this topic, we invite you to enter them into the chat window and we will take live questions at the end. Our presenter today is Alex, who is an engineering support co-op here at ProLim in our Cincinnati office. With 4 years of CAD experience, Alexander brings a strong foundation of technical skills and a deep understanding of design software to his role. His expertise combined with his academic journey enables him to provide valuable insights and support to engineering teams here at ProLim. Welcome, Alexander. The Tech Talk is now yours.
Hello, everyone. Before we begin today's Tech Talk, I would like to mention ProLim's YouTube channel. Every Thursday, a new Tech Talk is published online regarding a different topic covering Siemens digital products. Under playlists, the Tech Talks are organized based on the different products. Now begin today's topic. Thank you for joining today's Tech Talk regarding NXCAM. My name is Alex Brewing, and I'm an NX application engineer for ProLim. And today's topic is NX Toolpath verification and animation. Today we're going to cover the legacy toolpath visualization. First, covering what it means for it to be legacy status, then reviewing how the feature is currently set up. Next, we're going to take a look into the newer method of toolpath display, which is toolpath animation. We will do this by reviewing the animation and display ribbon of the Home tab and how it can be customized for the ease of use. Then we will locate most of the corresponding options from visualization to animation. Finally, I will demonstrate using the new toolpath animation and how it can provide a smoother workflow. Once again, Siemens has designated toolpath visualization as legacy, as can be seen under the additional information found in the customer defaults. The legacy status is the first step in the process of phasing out or replacing a feature. By designating a feature as legacy, Siemens is making users aware that the feature will not be enhanced in future versions and may potentially be removed entirely as a feature. So to recap, legacy features are still available, are no longer receiving enhancements, are not recommended for use, and may be removed in future versions. Now moving on to the toolpath visualization method, we can quickly go over the current options. The initial pop-up that will appear is the replay option. Because it does not include material removal, this is the faster animation method. On the right is the 3D dynamic. This option does include the material removal and includes more options to account for that. I will go over these options more in depth in the next, so to briefly introduce the common options between replay and 3D dynamic, we have path listing, which lists 9 path motions at a time, a list slider to go between the different path motions, a feed rate display, a tool display, a toolpath display with the number of motions, an animation speed slider, and the animation controls. Now we will view this in NX. Now that I have NX open, let's begin by locating the legacy toolpath display. As long as the toolpath verify is left on in the customer defaults, it can be found by selecting an operation under Home, Operations, Verify Toolpath, or by right-selecting the operation, dropping down Toolpath and selecting Verify. Or when editing an operation, it can be found in the Actions under Verify. So let's open this up and take a look at the options one more time. Here we have the path listing with the path listing slider. And under Replay, we have an option for the tool display and the toolpath display. We also have gouge and collision settings, where we can check for gouges and check for collisions against the tool and holder. And we also have tool shape for checking, where we can change it from tool parameters to a solid assembly. We can also change the gouge check stock from automatic to user defined. And we can display the gouges and list them when finished. Under 3D dynamic, we have the same tool display and the toolpath display. We also have options for the IPW resolution and its display options. The IPW can also be saved out either with the operation or with the component. It can be created, deleted, or analyzed. And we can show as 3D or show as spinning 3D. We can also check for IPW collisions and check the tool and holder. We have options for collision settings, where we can pause on collision, check between the operations, check on tool change, and check on tool axis change. At the bottom, we have our animation speed slider and the animation controls. Now let's look at the new toolpath display options. Here's the animation controls with different play options, including play, play next, step forward, and fast forward. All of these options can also apply in the backwards motion, with play backwards, play to start of motion, step backward, and rewind. Along with this, we have an animation speed slider. I will go ahead and press play. And you can see how this operates. Moving on to the display, the toolpath can be toggled on or off, and an option to select the toolpath is also available. So when it's selected on, I can select along the toolpath, and the tool will jump along to that point in path. Other options available are the tool display, which can be changed from tool, the tool without holder, tool assembly, axis, and a point. Along with this is a toggle to show the non-cutting moves. So here we can see a non-cutting move in which it retracts upwards. I can select this and it goes away. And over here is an option for more options. The More tab shows options for different toolpath color schemes and toolpath selection options. So we can do motion type, operation, tool. We can configure the toolpath and its colors. And then here's snap options and point displays. Now I would like to quickly go over how you can customize the galleries for personal preference. This can be done by right-selecting in the gallery and pressing Customize. And from here, the icons can be rearranged, renamed, and resized. This includes moving them out of drop-downs. So here I can rename it, I can resize it. And I did this by right-selecting the icon while in customizing. I can also drag it over, and I can choose whether or not it displays its label. As for now, I'm going to reset the ribbon back to Cam Advanced, just so I can map the features over and we're all on the same page. Now that I reset my Home tab, I would like to briefly map all of the legacy options onto the current method. I'll begin by going to an operation and selecting Verify Toolpath. Underneath Replay, we have the Tool Display, which can be found in the Display options. 2D Material Removal, which can be found in the second dropdown. And Gouge and Collision Settings, which can now be found in the Check Toolpath, which I will go over later in the Tech Talk. For 3D Dynamic, we have the same Tool Display and an IPW resolution, which can now be found underneath this dropdown. We also have display options, which are now found in the customer defaults. The IPW can still be saved using the second dropdown underneath Save IPW. An option to check for IPW collisions and check tool and holder are also found in the Check Toolpath. And finally, at the very bottom, we have the Animation Speed slider, which is underneath Toolpath Animation, and the Animation Controls found in the same location. Now let's move on to see how to verify against any gouge or collision. This new method involves using the Check Toolpath and Toolpath report, along with the Validity report. Starting with the Validity report, this feature will display checkboxes that will provide information as to whether gouging or other criteria have occurred within a specific operation. This can be used to quickly monitor the status of multiple operations. So here we can see we don't have a feeds and feeds. There is not a robot, so robot rules do not apply, but that would not fail our summary in this instance. Here I can also select the second operation, and it will show me the same status. I can also select the group of operations, and I can see whether or not the entire group has failed and where it has passed altogether. After using a validity report, if any criteria is not met, whether it fails or it is unknown, the Check Toolpath feature will allow a specific report to be generated that will list all the findings. Let's look into this. So here we can see the Check Toolpath. I will select the first one, and I will check it. Here we have the options from earlier, where it can gouge check against a part, and do a collision check against the IPW. Here we can change the tool shape, and we can change the gouge check stock from automatic to user defined. We can also stop when a limit has been reached. So if there's 100 collisions or gouges, it will stop and it won't waste time looking into more of them. So I will select OK. And here we can see there's nothing to be dropped down. So I'll check out the second one. Here I will do a check toolpath. I'll keep the same settings. Here, every asterisk shows a collision, and it also reports it down in specified detail in this report. I can also have it toggle in between each one, and here's where I can use my play to end of motion. So I can see where the gouge collides. I can also create a tool sleeve that'll create a facet body that will highlight every single instance of a collision as a result of an intersection between the tool and the part. And I can also change the display for selected only. So I can display each collision at a time. For the final part of this tech talk, I would like to take the time to demonstrate how using the toolpath animation and display will allow for a smoother workflow. I'm going to begin by going to my operation navigator, and I'll just create an operation underneath floor facing. For now, I'll just call it a cavity mill, and I'll select OK. The first thing you do is ensure all of your options are set properly, and you'll select generate. In doing so, you'll see that the toolpaths have been displayed right away, unless there's a collision. Oh, here we see portions of the toolpath would have caused a collision. I'll go ahead and ignore this for now. So now that the toolpaths are displayed, the very first thing I can do using the toolpath animation is just click play. I can also toggle this on layer by layer, and I can go down and up as I need it. Along with this, and I neglected to show it earlier, is the display IPW. In doing this, I can watch it get cut interactively. I can also choose to display the toolpath or not, or whether or not I want to hide non-cutting moves. While this is also playing, I can also display the tool, as mentioned earlier. I'll go ahead and pause this for now. Now, the legacy method of doing the same process would involve selecting verify and being taken out of your operation navigator, operation dialog box, and going to your toolpath visualization dialog box. Here, in order to get the IPW to display, we'll have to go to 3D Dynamic, step it one forward, adjust the speed as we'd like, and then select play. And then to exit this and go back to your operation, you'll have to stop it, select OK, and then you're back. Now for now, I'm going to get rid of this operation. Now let's say that we already have the operations available and we just want to do a simple gouge check. The legacy method involves verifying your program. So go toolpath, verify. Ensuring that your collision settings is pause on collision. And then turning your speed up. You can choose to suppress your animation or not. Suppressing the animation will allow it to load faster. However, it won't show you the location of the collision. So for now, I'll click play. And here we can see the holder and the IPW are colliding right here. You can go ahead and press continue. And it'll continue showing me the different collisions, highlighting the tool in red and telling me what's colliding. So I'll go ahead and press stop. The new method of doing this involves selecting your program and selecting check toolpath. I guess initially you can do a validity report, and here we can see nothing's been checked yet. So I'll run a check toolpath. Here we'll do the cavity mill right away. I'll select gouge check and collision check against the part and IPW, and I'll select OK. Here you can see every single collision, and I can interactively go to the location. I can even toggle it on to selected only. Here it'll jump to each location. I can use this play next, and it'll show me the simple motion at which it occurs. So here I can slow it down, zoom in, I'll play next. And in this instance, I can see that the holder and the part itself are having a gouge. So for this specific instance, I know that it's because my tool is not long enough. So I'll go ahead and click OK. While I'm at it, I'm going to run a check toolpath on the entire operation. And here I'll select OK. Here my floor facing appears good, so it is just my cavity mill. My validity report also says that my floor facing is good, just for a second method of verification. My cavity mill has tool part collision and tool IPW collision. At the very end, they all fail the robot rules, but there is no robot applied, so it still allows it to pass. So going back to this instance, I'll go ahead and change my tool to be a longer end mill, which means I'll go ahead and generate this. And again, doing the legacy method, I can go toolpath, verify. I'm already on pause on collision, so I'll click play. And here we can see it load. It appears good, so I'll click OK. So for now, I'll run the check toolpath on it. And we can also see that there's no errors here. So I'll go ahead and click OK. And finally, I'll run my validity report. I'll select my workpiece. And here we can see my floor facing is still good, along with my cavity mill. So knowing this, I know that the code is good to post and run on the shop floor. So that concludes today's Tech Talk. Thank you for attending. And again, we have our YouTube channel, so we recommend you go and visit that.